Good day and what's up, everyone? This is Teacher Shadrach, your math teacher for today's video. All right, once again, good day to each and every one of you. All right, I hope you are doing great today. And uh, today, our topic that we will be studying is about algebraic expression. All right, uh, all right, right, yeah. Algebraic expressions. And before we begin our topic for this today, okay, I'm going to present to you once again our learning objectives in our lesson three in our mathematics subject. So on the next slide, so algebraic expressions. Okay, so these are our learning objectives. As you can see, I do believe I will put here my camera. Okay, all right. So our lesson of learning or lesson objectives is number one, we have the student should be able to differentiate between constants and variables in a given algebraic expressions. Secondly, the learner should be able to evaluate algebraic expressions for given values of the variables. And last but not the least, the students or the learner should be able to classify algebraic expressions which are polynomials according to the degree and the number of terms. On the next slide. All right, as part of our introduction, it states there that mathematical concepts, rules, and properties of numbers will not be easy to understand without knowledge of algebraic symbols and expressions. A single variable or a combination of mathematical symbols, variables, and constant constitute an algebraic expression. In this lesson, we will learn related terms in algebra and evaluate the algebraic expressions. Mastery of these concepts is fundamental to learn algebra. The next slide. Now, we have to recall that a numerical or arithmetic expression is any symbol for a number. We are familiar with the arithmetic statement. Just like, for example, 2 plus 3 is equal to 5. Okay? Now, there are times, however, when expressions have missing terms which are represented by a blank. Okay? A circle or a box. Or simply by X or Y like this, just like that. One of examples, if you notice, so circle plus box or blank plus blank is equal to 5. Or maybe, perhaps we can use X plus Y is equal to 5. Okay. Now, in the last expression, X and Y may take values from the set of integers that make the statement, should I say, true. For example, we have here 5 plus 0 is equal to 5, meaning in the last expression, we can take a values from the set of integers. We can substitute the x to 5 and 0 is y. So that's why 5 plus 0 is equal to 5. On the other hand, we have secondly negative 4 plus 9 is equal to 5. Okay? Also, 4 plus 1 is equal to 5. Negative 2 plus 7 is equal to 5. 3 plus 2 is equal to 5. Negative 3 plus 8 is equal to 5. 2 plus 3 is equal to 5. Negative 1 plus 6 is equal to 5. 1 plus 4 is equal to 5. Negative 5 plus 10 is equal to 5. 0 plus 5 is equal to 5. And negative 6 plus 11 is equal to 5. So this is are the arithmetics statements, and x and y may take values from the set of integers that makes the statement true. Okay, so these are the examples. On the other hand, there is an infinite number of values that can take the places for x and y. These letters are called variables. Please do take note. X and y is variables. And the number 5, which remains unchanged, is called constant. Okay. To understand the concepts, let us do the following activity. All right. On the next slide. Now, let us suppose numbers are assigned to letters of the alphabet as follows. We can see here A is equal to -1, B is -2, A is equal to 1, should I say, B is equal to 2, C is equal to 3, D is equal to 4, E is equal to 5, and so on up to Z is equal to 26. Using the above values, find the value of name by adding the values of its digits. So we have here examples. We have the word or the name Mary. So as you can see there, letter M is from the 13th alphabet of the English alphabet. Okay. And A is the first alphabet of the English alphabet. And R is the 18th alphabet. And Y is 25, the 25th alphabet. If you add it, if you sum it all, it is equal to 57. Okay. Just like also in the name Ace. So we have 1 plus 3 plus 5 is equal to 9. So that is an examples, right? To illustrate. Now, let's try this. Now, find the numerical value of each name. So, Ben, okay, we have here number 1, Ben. Letter B is the second one. Letter E is the fifth one. And letter N, if I'm not mistaken, what is letter N? I believe it is 14. All right. So um if we go back, right? 14, 2 plus 5 is equal to 7, which is E, plus 14, it is equal to 21. So the numerical value of the name is, of the name Ben, is 21. Now, the second one is Laura, right? So can you try if on your own? All right, that's your assignment. Okay. On the next slide. Okay, letter B. Determine the values of the whole expression. Follow these examples. So let us determine the values of the whole expression. Take note, substitute the given value of the variable. Okay, so on this method, we are going to substitute the given value of the variable. So we have here letter A. What is the value of x plus 8 if x is equal to 3? So this is the solution. X plus 8 is equal to 3 plus 8. Say, again, it states there that the value of 8x plus 8 if x is equal to 3. So we are going to substitute the number 3 to the value to the variable of x. So kaya naging ganyan, 3 plus 8, right? So it's equal to 11. So that's the answer. Okay? Second one, letter B. What is the value of x or x2 minus 3 if x is equal to 2? I do believe it's a typo. I believe that is 2x, right? I forgot to edit it, but it is 2x. Okay, correct me if I'm wrong. Now, if we are going to substitute it, it will be 2x, all right? 2x or 2 times 2 minus 3. So it is equal to 4, all right? The 2 times 2 is equal to 4 and minus 3, and the answer is 1. Okay, I hope you do understand. On the next slide. Now, let's evaluate this. x plus 2 over y minus 1 if x is equal to 1 and y is equal to 2. So as you can see there on the solution, so x plus 2 over y minus 1 is equal to 1 plus 2 over 2 minus 1. So let's go to first at the numerator. So we have 1 plus 2 is equal to 3, and the denominator 2 minus 1 is 1. All right, so the answer is 3 over 1 or 3. Okay, I hope you get it. Next, we have letter D. What is the value of x raised to 3, all right, or x cubed plus 2x plus 1 if x is negative 1? So we are going to substitute the value of x, okay? So we have here the x cubed. So we are going to transfer or to substitute the value of x. So it will be negative 1 raised to 3 or cube. Negative 1 cube plus 2 minus 1 or 2 times negative 1 plus 1, right? So here's the process of the solution. So negative 1 raised to 3 is negative 1 minus 2 times negative 1, it will be equal to negative 2 and copy the plus 1. So that is the process of solution. Now, negative 1 minus 2, all right? We are going to add first by the rule of PEMDAS. So it's depend. And when we say PEMDAS, parentheses, exponent, multiplication, division, addition, and subtraction. So we can use the PEMDAS when we are solving an equation like this. So we can at first 2 plus 1 is 3 minus 1 is negative 2. Or no, negative 1 minus 2 is equal to negative 3 plus 1 is negative 2. That's the correct one. Okay. All right. Now, these are terms in algebra. So those examples that I discussed, okay, that is the part of our introduction. Now, let's proceed to our uh, main topic, which is the terms in algebra or terms in algebraic expression. Now, letter A, positive integer exponent, okay, positive integer exponent, where a is not equal to 0 and n is a positive integer, right? Now, the expression 2 times 2 times 2 times 2 can be written as 2 raised to 4 or 2 to the power of 4. Okay? So our base would be number 2 and number 4 is the exponent. It is our exponent. Now, similarly, x times x can be written as x cubed or x raised to 3. The variable x is the base and the number 3 is the exponent. The exponent tells how many times the base is used as a factor. Take note of that. Okay. Now, on the next slide. So here are other illustrations for us to be able to understand clearly. So as you can see here, negative 5 raised to 3 or negative 5 cubed is equal to negative 5 times negative 5 times negative 5. It is equal to negative 125. Okay, if you solve this step by step, so first negative 5 times negative 5 is equal to positive 25, and positive 25 times negative 25 is negative 125. Okay, I hope you get it. Now we have here another examples. We have 1/2 raised to 2 or 1/2 cube, 1/2 squared is equal to 1/2 times 1/2. It is equal to 1/4. Okay, you got it? All right.